Welcome to Unit 6, Lesson 4, The Movement of Electrons. Let's start with some background information. First off, Niels Bohr adopted some of Planck's assumptions and explained the phenomena in this way. He said that electrons in an atom can only occupy certain energy levels. If we look here and consider each one of these horizontal lines an energy level, as we can see here with the green, we can occupy from one energy level to the next. With some additional energy, we can go from one energy level up to an even higher energy level. You can kind of consider this as if you were walking up stairs. This would be maybe the first stair. How much energy do you need to add to go up one stair? What if you wanted to skip stairs and go up 2 stairs? You need to add more energy. It requires more energy from you to do 2 stairs at a time rather than 1 stair. So that is somewhat of an introduction. Another thing that Niels Bohr adopted from Planck was that electrons in permitted energy levels have specific allowed energies, and these energies will not be radiated from the atom. He also stated that energy is only absorbed or emitted in such a way as to move an electron from one allowed energy state to another. The energy is defined by E equals hv, where E is energy, and h is Planck's constant, and v is frequency. One of the things we need to understand is that electrons will either occur in the ground state or in the excited state. The ground state is when electrons occupy the lowest available energy levels. The excited state is when electrons no longer occupy the lowest available energy levels. Recall back here, here would be the very lowest energy level down here at 1. The next energy level would be clear up here at 2. Down here would be considered ground state, almost like you were on the ground level. You go up 1 stair, you are now here at energy level 2. So get out your periodic tables, and we're going to look at some possible excited states for sodium. Sodium has a ground state of 2-8-1. We will soon get into the relevance of what these numbers mean, but for right now we're going to look at these as our number of electrons. And if we add up 2 plus 8 plus 1, we get 11. And if you look at your periodic table, sodium has the atomic number of 11, so we are guaranteed that this does indeed match sodium. For sodium to be in an excited state, these numbers will not be represented in this way. They will change slightly. Here we now have 2-7-2. Since this does not match identically to what is listed on your periodic table, the sodium is in an excited state. And you will notice that it tends to be the last 2 numbers that we change, and we tend to change it only by 1. Since these do not match the original ground state, each one of these numbers represent an excited state for sodium. So let's take a practice. How can we tell if the configuration is ground or excited state? First, we need to add up the total number of electrons in the configuration. And in other words, add up all of the numbers, and whatever that number equals will tell you the atomic number of the atom we are working with. You will then use that number to determine your element. If it matches the numbers in the particular numbers, such as 2-8-1, then that is the ground state electron configuration for that particular element. If it does not match, then it would be considered in an excited state. So let's do some practice. For example, identify the electron configuration as being a ground state or an excited state